To prepare for the coming wave of IoT device releases, Ubiquiti has this SuperLink device available now. It's pretty small, kind of industrial look, and with a huge antenna. It only has a 100 megabit Ethernet port. You don't need higher speed for such type of device. The SuperLink will support the new SuperLink sensors in the future, not now yet, and it's bragging about 2 kilometers link range, but it doesn't say anything about the technology under the hood. I assume it's Ubiquiti's proprietary approach. And then regarding this BLE support, this is the main focus for this video. It supports up to 7 existing Ubiquiti sensors with improved long-range connectivity comparable to Wi-Fi. It implies the existing Bluetooth in the U6 access points is not comparable to Wi-Fi coverage. BLE stands for Bluetooth Low Energy. It's a network technology intended to provide considerably reduced power consumption and cost while maintaining a similar communication range. It is independent of classic Bluetooth and has no compatibility. In this Ubiquiti document, you can find the available U6 access points which support BLE. In fact, there is only one product within Ubiquiti's product lines that requires BLE, which is the UP-Sense, the all-in-one sensor. In my lab environment, I have a UNVR. It hosts a SuperLink and 2 all-in-one sensors. And for the 2 sensors, you can see they are currently connected with the SuperLink. And one is very close to the SuperLink, the other one is pretty far away, but you can see the signal strength is not bad. In this video, we are not going to talk about from end user perspective how the sensors and the SuperLink work. Instead, we are going to dig into the backend to see how BLE works over there. For a UniFi IoT device, the SuperLink is managed by a console, which is a UNVR. Of course, if we want to SSH into the SuperLink, we need to do something on the console. But it's not very direct and very easy to even enable the SSH. Right? You didn't hear me wrong. Even for such a small IoT device, Ubiquiti supports SSH. To enable that, you need to have some backend work. Before doing anything, if I try to SSH to the SuperLink, by the way, I got the IP address from the UniFi UI. Then if I try it, see, connection refused. So this error message means we need to do something to enable SSH. However, in the UniFi Web UI, if you go to settings for control plane, go to console, yes, you can enable SSH. Here, I have already enabled it, but this is just for SSH into the console, into the UNVR. It has nothing to do with this SuperLink. Then how we can enable SSH to the SuperLink? Just like UniFi Gateway, for managed devices, you need to enable SSH in another setting. You go to System, then you go to Advanced. So here, if Ubiquiti wants you to SSH into the IoT devices, it will have a SSH setting. But no matter how hard you try, there's no apparent way to enable SSH. In fact, it is hidden here. It is called recovery code. Ubiquiti deliberately hides the real purpose of this setting. In fact, it's simply a password for the managed devices if you want to SSH into it. It doesn't matter whether it's UniFi Protect cameras or in this case, it's a UniFi IoT SuperLink. What you are setting here, it is the SSH password. Okay, I already set one password here. Again, I got the error message in the lower part of the screen, right? So that means we are still missing something. Let me first SSH into the console, not SuperLink. So here I use the username root. For password, I need to use the one I set on the UI in the control plane SSH setting because it is for the console, right? Okay, I'm in. Then let me go to user share. So let me go to the protect folder and go to app config. There are two configuration files. The default JSON file is the one I want to change. Let me edit it. If I try to search SSH, see, there is a setting here, but it says false. What I need to do is change it to true. That's it. Then save the file. So the configuration file is changed, but it won't be effective until I restart the UniFi Protect application. Of course, I can restart it either by rebooting the console or by restart the app from the web UI, but let me do it from backend since I'm already here. Service UniFi Protect restart. Okay, restart it. I'm done with the console change. Let me exit the SSH. Now let me try to SSH to the SuperLink again. By the way, I use the user name Ubiquiti. See, now we have different prompt. Instead of error, now we need to input password. It's a great sign. Then for password, I need to use the password I set in the system instead of the control plane. I go to system, advanced. I will use this password. Okay, I'm in. Interestingly, the operating system is BusyBox, just like UniFi Switch. If the operating system is a regular Linux, to configure and manage BLE, you use HCI tools. HCI stands for Host Controller Interface. But here, if I run command, for example, HCI config, it's simply not installed inside this SuperLink. But I know there are several special processes, BLE connection and the BLE bridge. They are related to the Bluetooth BLE functionality. So for this SuperLink, let me try to search for them in the current processes which are listening on network ports. So let me run command netstat AEMP. Try to see whether we have any hit regarding BLE. We have several hits. See these two listening ones. One is BLE bridge 2 daemon and the other one is BLE connection daemon. Then if I search the whole system starting from root folder, if I try to find the BLE related configuration file, no, then let me try JSON. Okay, we have two hits. So these two files are the configuration files I want to look into. If I pick one of them, for example, this BLE connection JSON, if I try to VI it, you can see everything is within one line. It's not very convenient to look into it. So instead of directly viewing them inside the SSH, let me run scp command to copy these two files to my local machine. Okay, copied. Now I can open them locally. In the lower part of the screen, I open the two files. Apparently the right side one for the BLE bridge is much simpler, so let's start from it. It configured two main things. One thing is how the BLE bridge will communicate with the BLE connection. So in the diagram, you can see BLE bridge is here, BLE connection is here. So the bridge will be in the middle between two different things. From your UniFi console, the UNVR, it runs the UniFi Protect application. That application will call the service provided by the BLE bridge by using WS or WebSocket. And then the BLE bridge will be responsible to relay the request to the BLE connection. Your UniFi Protect application will not directly communicate with the Bluetooth hardware. So this is the purpose for BLE bridge. So you can see here it specifies the Bluetooth information, more specifically the BLE connection. It's running on the same Linux machine for the SuperLink, and it has this special part 8383. For the Protect application to connect to BLE bridge, of course the connection need to be secured. So this is the certificate and the key configuration. Okay, this is the simple configuration for the BLE bridge. Let's move on to the left side. The real secret is behind this BLE connection configuration. For the BLE connection daemon configuration, the first part is about the interface setting. It gives the interface this name, and here it specifies the driver settings. So the name is Blue Gecko. As I understand, is the driver provided by Silicon Labs for this particular chip, and then it specifies the MAC address and the firmware image path. Next, it moves on to device setup about the hardware. So here you can tell from the vendor is Silicon Labs, and here it is the chip. If you are interested, you can search this particular chip. It has all the introduction about the functionalities. Then under resources, it specifies the advertised count and connection count. Interestingly, the connection count is 8. If you compare the right side, it says 7 sensors. I believe it's not coincidence, so 7 equals to 8 minus 1. Then here it has the very detailed capacity settings for the hardware. For example, here the transmission power, you can see the same thing under the technical specs for SuperLink. One thing I want to stress is this part, the scan physical, connection physical, advertise physical. See here it says 1M and coded. This is important, is related to the so-called improved long-range connectivity for this particular SuperLink. So here just some very simplified background information. 1M or 1M PHY was originally introduced by all BLE devices. So basically it means 1 mega symbols per second. Later 2M PHY was introduced, achieved double the speed of 1M. Here we are talking about coded PHY, which means it is still 1 mega symbols per second, but it was introduced from Bluetooth 5, achieves ranges up to 4 times of the original range for 1M. That's why the coded PHY is bragged as long-range BLE in the Ubiquiti's marketing material. Based on what I know, the long-range Bluetooth or coded PHY, it can extend the range of Bluetooth device from dozens of feet all the way to about 1 kilometers. After hearing this, you may think, okay, is that what's behind this bullet point about the future SuperLink clients? Here it says up to 2 km. Is that the same technology? No, the SuperLink for future IoT devices are based on different technology. Another thing is, okay, so because here Ubiquiti brags, okay, the SuperLink have the improved long range. Does that imply in the U6 access points, they are not using the same coded 1M PHY, so that's why it's not long range? Just to double check that, I downloaded the same configuration files from my U6 enterprise. Let's compare them side by side to understand whether the coded PHY is a new thing for this SuperLink. In the right side, I opened the U6 Enterprise BLE connection configuration. So let's compare it to the new SuperLink. So you can see due to the hardware difference, so the driver in U6 is Bluetopia and the device is from Qualcomm, and this is the chip name. It has the same connection count. That's why for U6 AP, it also supports 7 sensors. And then when it comes to capabilities, you can see it has the same setting about the PHY. So it's the 1M coded PHY. And you can see for connection PHY, it even has 2M specified. So yes, maybe for SuperLink, it has improved the range than U6 access points, but that improvement is not because of the Bluetooth long range setting. Okay, let's go back to the SuperLink's BLE connection JSON file. Here it specifies the API server's port number. As shown in the diagram, the BLE connection daemon acts as the API server. and the BLE bridge is just a middleman, so it will relay the request from UniFi Protect application. BLE connection is the real API server. The remaining part is very self-explainable. So now we talk about the configurations. As the last part, we will see the communications in action between the SuperLink and a sensor. For BLE communication, the two parties, one is master, the other one is slave. In our case, the SuperLink is a master, the sensor is a slave, but the slave serves the GATT server, and the U6 link is a GATT client. What's GATT? It's a acronym for generic attribute profile. It makes use of generic data protocol called ATT, or attribute protocol. Here I show you what's the profile, what's the service, what's the characteristics. Everything served by the sensor, which is the GATT server. It has a profile, defines multiple services. For each service, it defines the characteristics. During the communication, the GATT client, which is SuperLink, it will send a request through BLE to GATT server, and the GATT server will respond back with all the profile service characteristics information. So that's how the SuperLink device will know the information from multiple sensors it connects with. From the lower part, the two configuration files, one thing you can notice, for log, they are both set as debug level. It seems that Ubiquiti is not very confident about its BLE products. That's why even for the product on sale in production, they still set the log level to debug. But that's not a bad thing for us for this video, because we can simply monitor the syslog. We will understand how the two devices communicate with each other. Okay, let's get started. For the SuperLink, the syslog is saved in this folder, mount log. There are multiple files. This one ending with 0 is the latest one, the current one. So let me display the file change in real time. Okay, then in the upper right for the sensor 2, let me restart the sensor so that we can monitor the whole connection and synchronization process. So let me click restart. You can see the sensor is disconnected. Once the restart is done, you will see the connection information. Okay, fast forward. Okay, it seems it's quiet, so let's go back to the beginning. Let's see what really happened. See, starting from this one, BLE connection, ask the driver to start the discovery process. You can see it's using the coded, the long range BLE way to do the connection. And then see this one, the UniFi Protect, which is from this IP address, WS meaning WebSocket. It sends a API request to the BLE bridge, and it try to open what? Now I see this MAC address. This is the MAC address for the sensor. Because the Protect application knows the sensor was rebooted, so it's trying to see the current status. Then see, the bridge will start this activity, connectivity control. It will request the device information. Then the BLE connection will send the request to the Bluetooth interface, trying to connect to this particular sensor. And then you can see the connection is opening and it's trying to connect to the sensor. Then see connection opened with this sensor, and it has master and it's bounded. Since the connection is established, the next is to start the GATT sync. So the SuperLink will send a request to the sensor to sync attributes. Then you can see the whole bunch of information exchange between the two devices. Then see this one, the GATT synced. Okay, it's just an example process after I restart the sensor. So you see it in action. It's simple communication between the two BLE devices thanks to this architecture based on both software and hardware. You see how the UNVR hosting protect application works together with the SuperLink device and connect to the all-in-one sensor. Okay, this is the end of the video. Thanks for watching.